So this is a series and we are required to find the value of k. Now this question requires a bit of a careful observation. Always you must think from the perspective of what information you already have. Now at first glance this does not look like a normal AP arithmetic progression or geometric progression or harmonic progression. But if you see the RHS, it's mentioned as k into 10 to the power 9, and LHS is some sort of an expansion. So, one way to approach this is to simplify the LHS and try to bring it in terms of 10 to the power 9. So, we'll start from there. So, let's focus on LHS. So, if I take 10 to the power 9 common, this becomes 1 plus 2 into plus 3 into 11 squared 10 to the power 7 upon 10 to the power 9, and this goes till 10 into 11 to the power 9 upon 10 to the power 9. Okay, let's take this further. This becomes 2 into 11 to the power 1. Now 10 to the power 8 cancels out, so this is 1 upon 10 plus 3 into 11 squared, again 10 to the power 7 cancels out, so 1 upon 10 squared, and this goes till 10 into 11 to the power 9 upon 10 to the power 9. Now this series takes some sort of a structure. If you see carefully, this simply becomes 11 upon 10 to the power 1. The third term becomes 11 upon 10 whole squared plus dot dot dot, and finally till 10 into 11 upon 10 to the power 9. Now let me just write a generic form. So this is 1 plus 2r plus 3r squared da, 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 10 to the power 10 into r to the power 9, where r is equal to 11 upon 10. Now this is a series that we are generally aware of, and this is called an arithmetic geometric progression. It's because it has some arithmetic properties. If I just remove this r thing, then this is some sort of an arithmetic progression 1 2 3 4 till 10, and due to r it becomes a geometric series. So it's a combination of the two, and for solving such series we use the method of difference. Okay, so let's assume this s is 1 plus 2r plus 3r squared plus 4r cubed till 10 into r to the power 9. Now write this again. This is a very general method and it's applicable for all of such kinds of questions, and multiply it with the ratio. So this becomes r plus 2r squared plus 3r cubed. This goes plus 9 into r to the power 9. So this is the previous term that is here. I multiplied it with r, and plus 10 into r to the power 10. The next step is to find the difference. So s minus rs becomes, if you subtract from 2r, this r goes, so this becomes 1 plus r. From 3r squared, 2r squared you subtract, so it becomes r squared. Similarly from this it becomes r cubed. From this term this is subtracted, so we get r to the power 9, and minus 10 into r to the power 10. So this becomes, now this is a simple geometric progression and the number of terms are 10, and the sum of a geometric progression is given by a into 1 minus r to the power n upon 1 minus r, where n is the number of term and a is the first term, r is the common ratio. So this, the first term is 1 minus r to the power 10 divided by 1 minus r, and minus 10 into r to the power 10. So s is nothing but I divided by 1 minus r. So this becomes 1 minus r to the power 10 upon 1 minus r minus 10 into r to the power 10. Now if you see carefully from this step, there was a 10 to the power 9 outside, and this was what we assumed as s. But look at RHS, it is k into 10 to the power 9, and the LHS is 10 to the power 9 into s. So basically s is k. So we know that s is k. So we just have to find the value of s. This will be our answer. So now let's substitute the value of 1 by r, which is 11 by 10. So let me write it down. 1 minus r to the power 10 upon, this will be 1 minus r squared minus 10 r to the power 10 upon 1 minus r. Now let's put the value r as 11 by 10. So this becomes 1 minus r to the power 10, 1 minus 11 by 10 squared minus 10 r to the power 10 upon 1 minus 11 by 10. Let's substitute. So if I take the LCM, 10 minus 11 will be minus 1, and I'm squaring it up. So 100 will go in the numerator, 1 minus r to the power 10 divided by, this will be minus 1 squared, which is 1, minus, this is 10 r to the power 10 upon, again 10 minus 11, which is minus 1 upon 10. So 10 will come in the numerator and this will become minus 1. Let's solve this. 100 minus 100 into r to the power 10, and minus will become plus 100 r to the power 10, right? So this r to the power 10 term cancels out, and what we get is 100. So the value of s, which is k, is equal to 100. So this is the answer. So answer is option